The third spectral parameter is called nuclear magnetic interaction, or in simply it is the ZEEMAN splitting. What exactly is the ZEEMAN splitting? The name itself suggests that due to the presence of a magnetic field, the nuclear energy levels get splitted. In other words, the degeneracy will split up. Degeneracy means the states of equal energy. The states of equal energy get splitted due to the presence of an external magnetic field. What is the source of this magnetic field? It can be external, that separately we are applying an external magnetic from an outside source, or it can be due to the presence of internal electron, the presence of the core electrons. What exactly the magnetic field, the magnitude of magnetic field? So the effective magnetic field, which consisting of four parameters. The B contact means due to the spin motion, the spin moment of the s electrons. S electrons are around the nucleus. Due to the spin motion or spin moment of the s electrons, a magnetic field is formed, that is known as B contact, magnetic field of contact magnetic field, or in other way Fermi contact, or this is also known as Fermi contact. Magnetic field due to the spin of s electrons around the nucleus is called Fermi contact. Second is magnetic field due to orbital motion. The orbital motion of electrons around the nucleus can also generate a magnetic field, that is called magnetic field orbital. Due to the spin moment of the electron, the spin motion of the electron, that create a dipolar magnetic field, that is the B dipolar. And finally the applied magnetic field, that we are applied separately from an external source. So these three magnetic fields belongs to electrons, the surrounding electrons. The magnetic field due to the surrounding electrons. B contact or Fermi contact, B orbital, B magnetic field due to orbital motion, magnetic field due to the dipolar moment of the surrounding nucleus, the surrounding electrons. And finally the B applied, that is B externally applied. So in total, this is the B effective, the magnetic field, effective magnetic field. And as a result of this effective magnetic field, which interact with the nuclear energy levels. Okay, so the spin content number, the spin content number, which split into 2i plus 1 sublevels. The nuclear spin content number split into 2i plus 1 sublevels. Okay, so for example, if it is half, it is split into 2 sublevels, plus half and minus half. So this phenomena, this splitting of degeneracy of energy levels of a nucleus is called ZEEMAN splitting or nuclear magnetic interaction. So let us consider the energy level diagram. So the source nuclear, upon emitting the gamma radiation, due to the difference in chemical environment, this is also a difference in chemical environment. So there must be an isomer shift. So the two energy levels, the degenerate energy levels get splitted into, in accordance with the 2i plus 1 rule, 2i plus 1 sublevels. So 3 by 2 splitted into 4 sublevels, 3 by 2 plus half, minus half and minus 3 by 2. And the ground state half sublevel of absorber, the sample split into 2. Okay, according to this 2i plus 1 sublevel rule. So what exactly the spectra we will obtain? So in order to obtain a proper spectra, so from this observance, the ground state is split into 2 and the excited state split into 4. So we can without any doubt we can say that there are 4 spectral lines, right? 4 spectral lines we will obtain. But no, that's not true, because in the case of ZEEMAN splitting or magnetic interaction, we are applying a selection rule. According to the selection rule, 0 or plus or minus 1 is the selection rule. So instead of 8 spectral lines, we will obtain only 6 spectral lines. This is due to the selection rule. So the transition between spin state of plus half to minus 3 by 2 gives a sublevel value, a spin core number of 2, which is not acceptable. So transition between plus half to minus 3 by 2 and minus half to plus 3 by 2 is not possible. As a result of that, these are the transition from plus half to minus half, from plus half to another plus half to the excited 3 by 2. Similarly, minus half spin energy level to sub level to minus 3 by 2, minus half to again minus half to plus half sublevel. As a result, we will obtain a sextet. Okay, 6 lines. The 6 lines are shown here. The y-axis is the absorbance, x-axis is the velocity in millimeter per second. So these 6 lines are. This is called magnetic or Zeeman splitting or nuclear magnetic interaction. Due to nuclear magnetic interaction, we are getting a hyperfine spectra because the spectra gets split into hyperfine spectral lines. So the spectra will provide a sextet spectra, and we can see that each trough gives a separate information on the magnetic property of the corresponding nuclear. So from the Zeeman or nuclear magnetic interaction, we can infer the magnetic properties, a miniature, the minimal magnetic property can be get from the spectral result of MÖSSBAUER spectroscopy. So let me repeat, due to the presence of an external magnetic field or the magnetic field inside the nucleus itself or inside the atom itself, the degenerate energy levels get splitted in accordance with the selection rule. The nuclear spin quantum number split into 2i plus 1 sublevels. Okay, and as a result of that, we will obtain a sextet in accordance with the selection rule 0 plus or minus 1. So when the ion complex experiences Zeeman splitting, this kind of spectra we will observe. A sextet of MÖSSBAUER spectra we will obtain from the ion complex due to the presence of Zeeman effect or Zeeman splitting. The presence of an external magnetic field, the degeneracy of the nuclear energy level splitted into 2i plus 1 sublevels. And as a result of that, in accordance with the selection rule 0 plus or minus 1, we will obtain a sextet. And from the spectra, what kind of information we will infer? From the spectra itself, it will give the magnetic properties of the specific nuclear, whether it is belongs to ferromagnetic, antiferromagnetic species, the spin state, etc. And in addition to that, the symmetry of that particular complex can be get inferred from the spectral details. How? Because the first 2 lines, the difference between the troughs of the first 2 spectral lines, the hyperfine spectral lines, and the last one, if this is A and this is B, if the difference between the first 2 spectral lines, say it is A and the last it is B, if A equal to B or A minus B is 0 or approximately 0, that particular ion complex, this is the case of iron, F57, that particular ion complex is cubic or octahedral symmetry. We can confirm from the MÖSSBAUER spectra. If the difference between the two troughs A and B are equal or A minus B is 0, the ion complex is cubic or octahedral symmetry. If they are not equal, if A minus B is not equal to 0 or A not equal to B, the ion complex is asymmetric in nature and which is not cubic or octahedral symmetry. So we can confirm the symmetry, the geometry and the coordination symmetry and the magnetic properties of the sample from the Zeeman splitting, hyperfine splitting data of the spectral lines.